Welcome. In this video, we're going to talk about how to go straight from the rule to the graph. So last video you did rule to table to graph, which is also a very efficient method, and you can certainly use it going forward for linear rules, but we really want to try and find more strategic ways, and that's kind of what math does. It tries to find more strategic ways to kind of solve problems down the road. So you should be taking notes on this, especially the major points here, and then try to get some graphs sketched with the slope triangles that I'll show you here. So rule to graph is the title of your notes. So when we graph lines, the graph of ym equals mx plus b, so the graph of this guy here is always going to be a line. And by line we mean like a straight line, like not a curved line. It's going to go forever in two opposite directions, okay? So a line, straight and shoots off forever in two directions. So the slope of the line is always your m value. And again, to review from last time, in another video you saw slope, and we want to remember that slope is the change in y over the change in x. And so whatever that number for m is, that's going to be our slope, change in y over change in x. And then b will tell us the y-intercept. Y-intercept. And so we can also think of this as the starting point, because when we did tile patterns in 8th grade algebra, you should have seen lots of examples where you looked for the start and how much it grew by. And so slope is also your growth. And so we might grow positive, we might grow negative, we might grow by a fraction, and we'll get into all that. The last thing that's important is the y-intercept and the x-intercept. Y-intercept is where it crosses the y-axis, and then x-intercept is where it crosses the x-axis. And so whenever we cross the y-axis, that means we didn't go left or right at all. So your point will always look like the following: 0 comma something, some number for y, it's going to be on the y-axis. And then the x-axis is the other way around. Now we have x as a value and 0 for y. So those are kind of important points that will also be helpful for unusual lines. So let's take a look at graphing this first one. So using this idea of growth and starting point. So I'm using I like to use that language, growth and start. But I notice that 3 over 2, that's my growth. And so yes, that kind of a peculiar growth, but 3 over 2 is my m. But even more importantly, if I want to think about it a little more carefully, it's change in y over change in x. So that 3 and 2 tell me two different things to change. And then your 1 is your y-intercept, or your start. Your y-intercept. Sorry, that's supposed to say int. So now we're going to start at 1 and grow by 3 over 2. So we're going to start at 1, and we always use our starting point first. So we're going to use our starting point of 1. So that's a y-intercept, so up at 1. That's my first point that I plot. Then the next points that I plot are based on my growth. So my growth, my change in y, remember change in y is 3. So that means in the y direction, I'm going to go up 3. So I'm going to start here, and I'm going to count 1, 2, 3. I counted up 3 from that point. And then I change x by 2. And since x is a positive 2, I'm going to go in the positive x direction of 2. So I go to the right 2, 1, 2. This is my next point. And again, if you're on using just regular old paper, you would start up at 1, and you could still draw your slope triangle by just counting 1, 2, 3, and then you'd go over 1, 2, and then you'd have your new point. And that's how you could kind of make a quick sketch. So you have your first point at 1, and your next point there, and guess what? All you got to do is connect them. Done. So that's how we draw a line quickly using slope-intercept. And so again, I'm going to connect these. And I certainly could get more points, but in math, we kind of just want to know that you can do 1 point, because if you can do 1, you can do many. So there's your graph of your line for 3 over 2x plus 1. So every time it's growth and start. So there are going to be a couple of particular cases, so we'll look at least 4 more examples here. So example number 1, sometimes there will be a whole number. See the 2 right here? So again, that's my slopes. Let me keep that in red here. So that's my slope. So 2 is my slope, and my y-intercept is -4. So I know the y is going to be -4 because that's always the second number, the number being added on or subtracted. So since it's -4, putting it down at -4. But the 2 needs to be turned into a fraction. So 2 is the change in y over the change in x. But 2 is not a fraction right now. So the way we make it a fraction is we always put it over the number 1, because 2 over 1 is the same as 2. So we need to remember that we're going to put this over 1 whenever we're given a whole number or an integer, a negative whole number, over 1. So now I'm going to rise 2. I'm going to do change in y of 2, okay, and then change in x of 1. So I'm going to walk up to 1, 1, 2, and I'm going to walk over 1. And that's going to be my next point. And again, I could do it again and again. 1, 2, over 1. And then I can sketch a line. So you'll be trying this. You should have tried it in our sync lesson together, but we also will be trying it on the MyOpen Math assignment, the problems you see below. So that's a positive whole number slope. And of course now negatives. So when you have a negative slope, again, my start point is the same. So my start point of 3, it's just a nice whole number. So I'm going to start up at 3 on the y-axis. And now my change in y is -2, and my change in x is 3. And so I'm going to from here go down 2, because the negative tells me the direction of down. Negative x's are down. So we're going to go down 2, and then we're going to still go to the right 3. 1, 2, 3. Because that is a positive 3, correct? Now I'm going to do one more point just so we can see a nice straight line. Down 2 to the right 3. See how it makes a nice straight line? And then I'm going to look at it, and it should look negative, meaning a negative direction. It's growing by a negative. And you see that this is going down. And so that's good. That means we did it right. So that's how we kind of want to work with negatives. So whichever number is negative, it tells me the direction I should go when I walk my slope triangle. So those are two typical ones that show you kind of two different things. But here's some weird ones. So these weird ones are when we have a whole number and there's missing stuff. So do you see how it's missing? So remember y equals mx plus b. But when you see y equals mx plus b, you see things missing. And what's missing is the x term. There is no x, right? So really we can think of this as 0x plus 4. That's the same thing, because 0 times anything is gone, would be 0. And so this tells me that my 4 is my y-intercept. So I'm going to be at 4. And I'm going to grow by 0. And hopefully you remember with that other slope thing, that means a flat line that doesn't go up or down, because it's not growing at all. But in this case, what I can see is 0 can be put over 1. And then I can go up 0 and over 1. Up 0 over 1. See that flat line start to emerge? I'm not going up at all. I'm going to stay flat. This is a 0 slope line. It only has a y-intercept, and it has no x-intercept. Another reason this is the right rule is because this is saying y equals 4 for everything. And that's true. No matter what point I look at, y is 4 all along this line. And that's what a line is. It's describing coordinate pairs, a relationship between x and y. And it doesn't matter what x is, y is always 4. Here it's the opposite. Instead of y always being something, x is always something. So we find x equals -3 on my graph. That's right here. That's 1 point. Here's another point. This is also when x is -3, right? Doesn't matter what y is. There's nothing here telling me about y. And so I am simply just going to graph all the points where x is -3. This is a vertical line, and what the rule will look like. It's a very weird rule compared to y equals mx plus b. But we find x equals -3, and that was over here. And then it's vertical from there, because it's all the numbers where x is -3. So those are the 4 types of lines you need to know how to graph. So practice that down in the problems below. Remember, you can try them many times till you get them right, so you can get a strong score, but also so you can get smarter as you practice. So thanks for watching.